Hey guys, and welcome back. Today we're going to be talking about constructing and solving equations from context. That means looking at word problems. So again, we're going to be, for our learning target, like I said, constructing, meaning reading those words from the word problems and pulling out words that mean mathematical concepts. To be successful today, we're going to be able to interpret words as mathematical operations. So I want you to be looking for addition, subtraction, multiplication, division, the equal sign, all that good stuff as interpretation from words. We're going to be able to put those words into math language, creating equations that we can solve multi-step linear equations for, and we've been practicing doing that these past couple weeks. So let's take a look at the first example. It says a town's population is 14,000 and is increasing by 160 people every year. A nearby town has a population of 24,000, and it is decreasing by 200 people every year. In about how many years will the populations of the towns be equal? Now I'm going to underline the last question there. It says, in about how many years will the populations of the towns be equal? Now, in that question, they are really telling you what we don't know, or the definition of the variable. So before we start writing out any of the equations, actually define your variable. Let's call it x. Let's say x is the number of years. Right now, what we're doing is we're kind of making a legend. What does x represent? Because we're going to interpret it into math language. What we also need to make sure we lay out is what each side of the equation will represent. What two things are we setting equal to each other? Well, it says in about how many years will the populations of the towns be equal? Okay, so we're comparing the two populations of the towns. Okay, so we'll say it starts out with a town's population is 14,000. Let's call that town A. Town A's population, we want to know when that's equal to town B's population. Okay, and we'll call town B that nearby town. Okay, so I put stars by where each of the towns were being described. Okay, so I want to know when the two are equal. So let's actually construct the math. How do we come up with town A's population? Well, it says in the words that a town's population, or we've been calling that town A, is 14,000. Okay, so they start with 14,000 people. And then the word increase is in there, okay? It's increasing. Increasing would mean we're adding people to it. Okay, so it's increasing by 160 people every year. So increase meaning plus, and then 160, but it's not just increased by 160 one time. It's increasing every year. Do we know how many years it's increasing for? No, that's actually what our x represents, the number of years. So it's 160 times the number of years x. We're adding 160 every time a year goes by. We're going to do the same thing with the opposite side and town B's population. So town B, or the nearby town, okay, we labeled that population B, has a population of 14,000, or not 14, I was reading the other one, 24,000 to begin with, and it's decreasing by 200 people every year. Okay, so just like I did last time, I'm going to first write down what the population starts with, which is 24,000. Decreasing would represent subtraction. We're taking away people every year, so we're going to subtract, and that was 200 every year. Again, 200 is not just being subtracted once, it's being subtracted every time a year goes by. So we got to multiply it by the number of years. So now we've constructed an equation. We literally interpreted from the words a mathematical equation that we can now solve to figure out what x has to be for these two populations to be the same, or for them to be equal. Now, both sides are simple. If I were to just look at the left side of the equation, I don't have any like terms. Okay, I can't put 14,000 and 160x together. Same thing with the right side. Those two are not like terms. I don't see any distributive properties, and I also do not see any fractions that I need to clear out. So I'm going to first get the variables on the same side. So I see negative 200x over there, and I see positive 160x over there. I'm going to move the smaller of the two, so I'm going to move the negative 200x over to the other side. Okay, so again, I'm going to practice my good organization skills. I'm going to rewrite everything I see just with the left side scooted over a little bit. And then I'm going to insert the opposite of negative 200x, which is positive 200x on each side of the equation. Which on the right side, negative 200x and positive 200x will become 0. And we're left with 24,000 on the right side is equal to, now I got to combine my like terms. I have 160x and 200x. If I drop down my 14,000, 160 plus 200 is 360x. Okay, so now I have a two-step problem. Okay, on the left side, I got to get x all by itself. That means I need to get rid of the 14,000 and I need to get rid of the 360. The one that would go first is the 14,000. That's the one that's being added to x. 360 is multiplying the x. So I'm going to do the same thing that I did before. I'm going to scoot the left side over, which I really already have enough space there for it. I'm just going to keep it spaced out that same way. And I'm going to insert the opposite. So the opposite of positive 14,000 would be negative 14,000. Which positive 14,000 and negative 14,000 becomes 0. That's exactly what we wanted. And now we have 360x left over. And we need to subtract 14,000 from 24,000, which gives me 10,000. And my last step to get x all by itself, divide off that 360. Okay, so I need to do 10,000 divided by 360 in my calculator. There we go. So let's see, round that. We'll round that to the 10th. We'll call that 27.8. So x is equal to about 27.8 years. Now remember, we should have real-life answers to real-life questions. So if you were to be asked this question of when the two towns' populations would be equal, you would say in about 27.8 years. Or if you wanted to even round that to the whole number, since there's no rounding instructions, you can say in approximately 28 years. Let's have you give this a try in your first U try. Again, look for words that would translate to plus, minus, divide, or multiply, and maybe even the equal sign. Look for All right, I've got another example here where we're going to have to logically construct an equation based on information that we're given. It says an apprentice pastry chef has been left alone to make 8 cakes. He cannot remember how much sugar to put in the filling. He knows the following. Each cake, not counting the filling, requires 1 1/4 cup of sugar. The head chef told him that he would need a total of 12 cups of sugar for all 8 cakes and fillings. Write an equation to represent the situation, then find the amount of sugar needed for the filling of 1 cake. Okay, so I'm going to underline that last part there. We're going to write the equation, obviously, in order to solve it. Okay, but that last sentence there says, find the amount of sugar needed for the filling of 1 cake. Okay, now I always underline that last piece because it basically tells us what our variable should represent. Let's call that x. Okay, the amount of sugar needed for 1 cake. Oh, the filling. The amount of sugar needed for filling of 1 cake. Now again, it's important for you to give yourself that legend of what x represents, because if you construct an equation, which is going to be the hardest part of this lesson, you construct an equation, you say, hey, Miss S, did I create the equation correctly? And I read it to you based on what x represents, you're going to be able to figure out whether it's correct or not, whether you set up the equation correct. So make sure you make yourself that little what is x. Okay, so I'm going to write down now that first bullet point. It says each cake, not including or not counting the filling, requires 1 1/4 cup of sugar. So let's talk about 1 cake. Let's construct something for 1 cake. We are going to need 1 1/4 cup of that sugar for the cake. But we're going to need to add the amount of sugar that we're going to need for the filling, which we don't know. That's x. So we have 1 1/4 cup plus some unknown quantity of sugar. Now, the second bullet point is telling us the head chef told him we need a total of 12 cups of sugar for all 8 cake fillings. So something's going to equal the 12 cups. Well, this here, that represented 1 cake. The sugar from the cake itself plus the X amount of sugar from the filling. Well, we have a total of 8 cakes. So we need to times that quantity, this whole quantity, by 8 to represent 8 cakes, equaling the 12 cups of sugar. So now we've created that equation. We're going to need to now use that equation. I'm just going to write it again below here. 8 times the quantity 1 1/4 plus x is equal to 12. And we're going to need to solve for x, because then we'll know how much sugar goes in one of the fillings. Now, my first suggestion here would be to change that mixed number into an improper. That's going to help us just do the multiplication in the distributive property. So remember, when we make something into improper, we take the denominator, we multiply it by the whole number, and we add it to the numerator. Okay, so when we go here, we multiply, and then when we come up here, we add, and then we just keep the denominator. So really, we are solving the equation 8 times 4 times 1 is 4 plus 1 is 5. Keep the denominator. So 8 times 5/4 plus x is equal to 12. Let's draw our line. Use the distributive property. 8 times 5/4, I'm just going to do a little side note over here. 8, or 8 over 1, times 5 over 4. We're just going straight across with the multiplication. Numerators times numerators, denominators times denominators. 8 times 5 is 40. 1 times 4 is 4. And then 40 divided by 4 is 10. So that actually gives us something nice. We don't have to deal with fractions now that we've distributed the 8 in. So I have 10 plus 8x is equal to 12. Now, both sides are simple. I don't have variables on both sides, so I can go ahead and start solving for the x. So I'm looking for addition or subtraction first. I'm going to scoot the left side over. I got to get rid of that 10. It's positive, so I'm going to put a negative 10 on both sides. Positive 10 and negative 10 becomes 0. Drop down that 8x. 12 minus 10 is 2. And then divide that 8 off. Now, please don't type in your calculator 8 divided by 2. That clearly says 2 divided by 8. So just reduce, okay, or simplify. Both 2 and 8 can be divisible by 2. So your final answer, 2 divided by 2 is 1, 8 divided by 2 is 4. So again, real life answers to real life questions. Question says, find the amount of sugar needed for the filling of 1 cake. Okay, so we would say 1/4 cups of sugar. That's our real life answer to this real life question. 1/4 cup of sugar would be for 1 cake filling. Okay, so that's the answer to that example right there. And there were 2 things we had to do. The first part, we constructed an equation. That's right there. And then the last part was solving that equation. That was this piece down there. So 2 pieces to your answer. Let's have you give this a try in your second you try. It doesn't look exactly the same, and that's the whole point. I want you guys to get experience with lots of different word problems. The skill here is to interpret. What words would represent addition, subtraction, multiplication, division? Use that logic to construct an equation and solve. Give it a try. All right, I've got one more word problem practice here that really hits close to home because it deals with what we are probably going to deal with the most in our lives, and that's working for money. It says an employee earns $7.25 per hour for the first 40 hours worked in a week and $10.88 for each hour of overtime. 1 week's paycheck is $344.40. Write and solve an equation to determine how many hours of overtime the employee worked. Okay, so again, I'm going to underline that last statement. Write and solve an equation to determine how many hours of overtime the employee worked. Okay, so that's what I'm going to call my X. Hours of overtime worked. Okay, always make that legend for yourself. Okay, so now it says they earn $7.25 per hour for the first 40 hours. Well, anytime you're trying to calculate how much money you're making, you're taking your amount per hour. That word per means to multiply. You're taking that amount per hour and you're multiplying it by the number of hours you worked. So for example, if you were babysitting and you earned $5 per hour, and you worked for 2 hours, you would earn $10. Okay? If you worked 1 hour, you'd earn $5. If you worked 2 hours, you'd earn $10. Okay? So that's just a little example of like where we're getting that per is multiply. Okay, you just multiply it by the number of hours. So you get $7.25 per hour, but that's for the first 40. So they already tell you what they want us to multiply by. Okay, so your first base pay, what you initially earned before overtime, is $7.25 times 40. Then you're going to add your overtime. Okay, so if I want to actually like label what's going on in this equation that I'm creating right now, it's like I'm taking my base pay, okay, that's this piece right here, and I'm adding my overtime, and that's going to equal my total. Okay, so I got my base pay plus my overtime pay is equal to my total. Well, 725 times 40 is my base pay. Now I want to figure out what my overtime pay is. Well, I don't know how many hours I worked overtime, but I know how much I get paid. Now I did how much times the amount of hours that I worked for my base pay. So I should do the same thing for my overtime pay. Well, overtime I'm earning $10.88. Okay, so I've got $10.88 times X, the unknown amount of hours, equaling the total that I earned, which they tell me is $344.40. There we go. So now I'm just going to simplify a little bit. I'm going to do that 725 times 40. 725 times 40. All right, so before you work overtime, you're earning $290. So this here becomes 290 plus 1088x is equal to 344.40. Now my whole goal here, I want to figure out how many hours of overtime I worked, so I want to figure out what x is. I got to get x alone. Well, 290 is being added, so a positive 290. So I'm going to subtract it from either side of the equation. That's going to give me 1088. X is equal to, if you need to, you can go back into your calculator, 344.40 minus 290. There we go. 54.40. Now, even though that just says 54.4, there's an infinite number of zeros after that. So if we're thinking dollars and cents, that's $54.40. So 54.40. And then we need to divide by that 1088. And once we type that in our calculator, we're going to figure out how many hours of overtime we worked. So 54.40 divided by 1088. I've already got 54.40 in my calculator, so I'm just going to hit divide. 1088 equals 5. Okay, again, real life answers, real life questions. So that was 55 hours of overtime. There's the answer to our question. Okay, so that was just another example, something that was a little more real life, where we can figure out what our overtime hours worked were. Let's have you give this a try. Again, dealing with money, give this a try in your third and final you try. All right, I've got one more question for you guys just to see if you can do it on your own without help from the key. But please make sure if you do need help still after these 3 examples have been shown to you, ask for some help during this last close and check. If you're having trouble constructing the equation, which is the hardest part, raise your hand, let me know. I have no problem helping you practice until you can get it on your own. Go ahead and give this last question a try, see how you do. All right, so that pretty much wraps it up for us today. We constructed and solved equations from context, or AKA word problems. Okay. And we interpreted words as mathematical operations. The ones that we saw the most today were things that would interpret to addition, subtraction, multiplication, and division. We do have other operations, though, in our tool belt. We have squaring, square rooting, cube rooting. We didn't see that today in our word problems because those would actually not be linear. You're going to study more of non-linear word problems having to do with exponential powers later on in high school. We did this in all 3 examples, interpreting those mathematical words into symbols. And then we did solve using multi-step linear equations. We've been doing that for the past few weeks. We did that in all 3 examples as well. All right, if you need to, please go back and rewatch any sections you may not have understood. Raise your hand, ask any questions to make sure you are fully understanding this lesson, and you may go ahead and start your Google homework. Have a great day.